Guys, today we are back with another problem, and today's problem is nothing but a medium based problem on recursion. And this problem is a rat in a maze problem. It's a very famous problem in the medium category problems. And what it is saying that we will be initially given a square, and matrix of order square matrix, so n and n, okay, size. It has to reach the destination, n minus 1, which is somewhere over here, and the matrix will start from 0 comma 0. So 0 comma 0. So matrix is going to start from here. Find all the possible paths that the rat can take from this destination. The destinations in the rat can move. So the rat can move in all four directions. Okay. And the rat can move up. You can say up. The rat can move down. Okay. The rat can move to the right. The rat can move to the left. Okay. Value 0 at a cell in the matrix represent that it is can block. Okay, so whenever there is certain values and whenever the value of that particular cell is 0, it means it cannot move. Means it is blocked. Okay, the rat cannot move. While the value 1 in the cell, it can travel through it. So instead of 0, if there is 1, which means travel is allowed. Okay, what else do we have? In a path, no cell can be visited more than one time, only once. Okay, and if the source cell is 0, the rat cannot move to any other cell. 0 means cannot move. Okay, so I'm going to just take the example of this particular and analyze whatever it is saying. Okay, so if I am taking the example as 1 0 0 and 0, after that 1 1 0 1, after that 1 1 0 0, after that 0 1 1 0 1 1. Okay, so if I check in this particular case, okay, if I check in this case, so what my entire 2D matrix looks like is this. Okay, so suppose I am at this position and I have to go to this particular position. Okay, what is the path I can take? So it is saying what is the path I can take. Okay, so when I'm going here, when I'm going over here, can I go in this direction? No, I can't. But can I go in this direction? Yes, I can. After that, can I go over here? Yes, I can go over here. After that, can I go here? No, I cannot go. I can go here? Yes, I can go. If I can go down? Yes, I can go down. If I can take right? Yes, I can take right. But I can take right from here as well? No, because no path can be visited once. If I can go down? No, I can't go down. So I have to go this way, and I have to go this way, and I have to go this way. So as per my assumption, what it is saying, first is down. Yes, down, confirmed. Then again down. Okay. Then right. Okay. Then they're taking this path. Then again down, right, then down. Okay. After that, right. So most probably it is telling right, like this. Yeah, it's like that, because over 0 we cannot move. And what about the other route? Down, yes, sorry, down, right. Okay, so I basically just showed the path, which was this path, to you, and this path is also a possibility. Okay, so how we are going to solve this particular problem? So let us come back to the particular problem and how we are going to solve this. So this problem can be solved using a recursive depth first search, DFS. Okay, we can be solving this problem using recursive depth first search. Okay. So how we are going to solve this? So we will be having an array list. Okay, and what else do we have? So we have to keep track of first there will be we will be having a function. Okay, so function is like an array list which will store the directions. So we'll be having a array list function. Okay, and in this function we are going to pass our matrix, say our matrix. Okay, so while we pass the matrix, first we have to check that whether it's a 0 or the last value is a 0. Then we are going to fill the array with -1. Okay, or else we are going to return the result. So first are the base cases. If the mat of 0 and 0 and the mat of n-1 or n-1 is equals to 0, then add -1. But what if it is not? Then we will be having a special array known as Boolean array. So Boolean visited array. Okay, so boolean visited array will store whether a particular cell is visited or not, visited or not. Okay, after that we'll be having a path. Path will help us to attach all the keywords down, left, right, top, like that. So once that is done, once our path is done, we are going to recursively call the DFS function, and we are going to traverse through the path by, say for example, I plus 1 and j, okay, and then I minus 1 and j, and I and j plus 1, okay, and we will be having say I and j minus 1. So we'll be saying this all the directions, all four directions recursively will be traveling. So this is down, this is up, this is right and left. So we'll be following all this path and we'll be solving this particular problem. Okay, so let's go for this and try to implement the code as fast as possible. Okay, so this is our driver code. So yeah, we will be having a DFS function, right? So, but before DFS, I'm going to check the base cases. So int n equals to mat dot alien length, okay, and if the matrix of first position is equals to 0, or the matrix of n minus 1 is equals to 0, what we are going to do is we'll be having a result. So array list of type string res equals to new array list. Okay, so you'll be having res dot add in quotation -1 for those values which have zeros. Okay, so and we will be returning the res. So once this is done, we'll be having a boolean visited array. So I can write boolean visited array equals to new boolean. We can give the size. Okay, we can have a string directions equals to, which will store the directions. Okay, so now we are going to call the DFS method, and in our DFS method we will be passing the matrix, the starting rows, columns, the visited checkpoint, okay, the length of the matrix, and the directions. Okay, and the directions. So once that is done, I'm going to add return results. Okay, so now I'll be focusing on making the DFS. So void DFS. In the DFS, what I'm going to do, I'm going to pass the matrix. Okay, I'm going to pass rows, columns, boolean visited array. So I can call it as visited. I can size string say directions. Is there anything else? So in the DFS function, what I'm going to call is, first I'm going to recursively just write all the directions. So my directions will be matrix I j vis, which for visited, n directions plus say down. Okay, for down, what do we have to take? We have to take row plus 1. Now similarly for all the four sides, for all the four sides, so we'll be having say down, up, right, left. For left, what we are going to do is we are going to do j minus 1, over here j plus plus, and over here I minus 1 and j. So down, up, right is done. Now we have to again check a couple of base cases. So if my I is lesser than 0, or my j is lesser than 0, or I is greater than equals to n, or j is as well greater than equals to n. Okay, what I'm going to do is I'm going to give a return function. After that, I'm going to check if the matrix of I and j is equals to 0, or visited means I have already visited. So visited of I of j equals to true, then I'm also going to return as it is. Okay. After that, I'll be checking. My. I'll be just checking. What I'm going to check is if my direction is at the last. Okay. And j equals to n minus 1. Then I'm also going to return. Okay. Initially, I will be considering my visited is true, but once I have done checking all the checkpoints, so I can again initialize it as false. When I've reached my endpoint, I can initialize it as false. Okay, so this was today's problem statement. I hope this works. So we have to just check once. There must be some error. I is less than 0 or j is so if mat of 0 and 0 is 0, mat of n minus 1 and minus 1 is also 0. Okay, res dot add as minus 1, return res. Okay, boolean visited, new boolean nn, directions. Okay, checked directions. Okay, then we are passing the matrix 0 0, visited and directions, result we are returning. Okay, in the DFS we are passing the matrix, rows and columns, boolean visited, the size, and string directions. Okay, so first condition is if our I is less than 0, or j is less than 0, or I is greater than equals to n, or j is greater than equals to n, return. Okay, if our matrix of I and j equals to 0, or visited is equals to true, then return. Okay, if it is n minus 1 and j minus 1, okay, j is equals to n minus 1, then when we are going to do is return. But before returning, result dot add, we have to add the directions. Okay, after that true, I plus 1 and j, I minus 1 and j, I and j plus 1, then I and j minus 1, false, DURL. Now let's compile. So that was a small mistake. Okay, so this is working, so I will write over here adding all 4. So make sure to like, share and subscribe to the channel, and we are looking forward to solve more such problems. Thank you.